Hey everyone, this is your friendly neighborhood math teacher, Mr. Bennett here, going over and finishing up chapter 9, working through 9.4. As you can see from the top, our title of today's section is Solving Exponential Equations. Now, the nice thing is, I'm going to kind of go quickly or quicker than usual through this because a lot of this we've kind of already done, which is kind of nice. The first page here is just some review of some of the major things that we've gone over in this chapter so far. It should look pretty familiar. It's kind of copy and pasted from some of the previous notes. Some big highlights, right? Exponential functions at the top, where our variable is in the exponent. We've got logs, which look like that, log base whatever of x. Our big rule of logarithms, right? The one really big thing that you need to know for sure is that a log, okay, the whole purpose of a log is that it answers the question, the base to what power gives us that big number in parentheses. And so we can kind of go back and forth between those two forms, being either a log, like this here, or an exponential function like b to the x equals a. And so again, right, my log base matches my big base. Our answer is our exponent, and what we're shooting for is the number inside the parentheses. Okay, so that relationship going back and forth, and we'll practice that here in just a second, is really key for this chapter. The other kind of quick notes to remember: a common log is log base 10, a natural log is log base e, usually we say ln. The logarithmic regression, okay, we won't be using this today, but I just wanted to kind of keep this in your brains because you do need to know this for your upcoming test. Using this logarithmic regression equation, y1 is approximately a plus b times the natural log of x1. That's where we put a table of values into Desmos, and then we kind of let Desmos create a graph, an approximate graph for us. The big thing to remember with log regression, one kind of little note you may want to make is that you need to make sure to switch your x and y coordinates. And so typically, if we're doing a problem like this, you're given a table with some x and y values, typically like a table of time, like the number of years, and then let's say like an income or something like that. And so we have to make sure that whatever our x and y is in that table, when we put it into Desmos for the log regression, that we switch those around. So we'd have a table that looks like this, and we'd have to make sure in Desmos that we switch around and make it look more like this. Okay, so just something to keep in mind that we did talk about earlier, but just that's a big important part of log regression. And then lastly here, we did talk about the transformations of logs. Okay, I didn't put all of the notes on here. You may need to go back through the chapter to look for those if you still don't know those. But it's mainly just focusing on what do a, h, and k all do for our function. A tells us two different things, tells us our reflection and our shape. H tells us our horizontal shift, and K tells us our vertical shift. The statement below, again, we've seen this before, we should know this by now. The big relationship is that the inverse of an exponential function is a log function, and the inverse of a log function is an exponential function. So they are inverses of each other. They undo each other, just like adding, subtracting go together, multiplying, dividing go together. Logs and exponentials go together. Then in our last section, 9.3, we did talk about the properties of logarithms and kind of looked at where they come from and how we can use them. So again, there were three definition-based properties. That's just kind of because of that rule, that question that we asked, the base to what power equals the big number. We looked at how do we, what information do we gather from that? And so we get the first big rule, which is this one. If our log base matches our big base, our exponent is our answer. The log of any base of 1 gives us just 0, and log base of the same base. Again, we can kind of think of that as a ghost 1 exponent. So that exponent, again, following that earlier rule, just becomes a 1. We then have the product property. Remember, product refers to multiplying. So when we multiply, we can separate and add. Quotient property refers to dividing. So whenever we divide inside of the parentheses, we can separate and subtract. Power property means there's a power, there's an exponent. So if my base and my other base, my log base and my big base don't match, then that exponent can just be put in front, which is what we see on the right side here. And then lastly, our change of base property. And a reminder, right, we don't always have to use this, but it is important to know because sometimes depending on what calculators we have access to, we may not be able to use log of base 2 or log of base 7. Like we might have to use log base 10 or log base e, our common log or natural log. And so if we have a log of a base we don't really like, we can use the log base that we want. Again, typically just common log or natural log. And then the big number goes up top. Our little log base goes on the bottom. Okay, so we've used those before. That was in 9.3. And so to start here, just a little bit of review. To be honest, you should be able to answer these questions on your own by now. So I would challenge you to kind of pause the video here and try these on your own for a couple of minutes. And then once you think you have an answer for each one, or can get as far as you can on each one, go ahead and play it and see if you got it right. But if you're totally lost, that's fine. You can just let it play. But I would challenge you to kind of pause and see what you can do on your own. So for letter A, it says rewrite the log as an exponential. So we can see that it says 2 equals log base 12 of 144. That means our log base is going to match our big base. Our answer is our exponent. And then that has to equal the big number in our log. So in this case, 144. And that's all we have to do is just rewrite it as an exponential function, which is this right here. So that's letter A. Letter B, rewrite the exponential as a log. So now going the other direction. So since my big base is 3, we're going to have log base 3. Since my answer here is 81, that's kind of what we're shooting for in the big parentheses. And my little exponent is the answer we're looking for the log. Okay, so the answer to a log should be an exponent. The answer for the log is the exponent. And that's all we have to do here. And then now letter C, use property of logarithms to simplify. So we have log of 5 to the power of 3 plus 3 times the log of 2. Something we want to notice here is they both have just plain log, which is log base 10. Now I see here that we have log base 10 of 5 to the 3rd power. So since my bases don't match, I'm going to go ahead and take that 3 and move it in front. So what we're going to get here is 3 times the log of 5 plus 3 times the log of 2. Now the other thing I can notice is they both have a times 3 at the beginning. So I'm actually going to use the GCF and factor that out. So we get 3 times the log of 5 plus the log of 2. So again, that 3 just gets pulled out to the front because that's the GCF. And then now we can recognize, okay, inside we have 2 of the same logs. They're both being added together, so that looks like my product rule, since I can separate and split, which means I can separate, they are separated and added. And so I'm just going to work up here. We can combine that into one log, so 3 times the log of 5 times 2, because that would be our product property. Simplifying that, we get 5 times 2 is the log of 10. And remember, common log is log base 10. And so if we have the log base matching the big base, then our exponent is our answer. Well, what's our exponent here? If there's no exponent, there must be a ghost 1. So we have 3 times 1, which is just 3. So again, being able to use those properties, kind of recognize those. To be honest, the kind of hardest part was probably seeing this GCF step. But yeah, being able to use what we can with our log properties to help us simplify those expressions. Okay, so that's all review. That stuff we should feel pretty good about by now. If we're still having questions on that, please make sure we get some help throughout the week. But now we're going to move forward.